In the first video, we looked how we could export AWR data and the necessary AWR augmented data to allow us to use the Oracle In-Memory Advisor to analyze the data from a remote system. So we didn't need to analyze the data on the host we were taking the data from. In this second video, we're going to look at how we load that data into a remote host, a remote database, and then analyze the data. On this remote host, I have two directories. I have an IMA directory, and this is where I've downloaded the In-Memory Advisor, unzipped it, and run the installation script to install it. If you want to see this, this is shown in the first video, how to actually install the advisor. I also have a repo directory, which I've created, and in there, I've got the AWR data in the dump format that was exported, and I've also got the augmented AWR data that was exported. So if we log into the database, the first thing I need to do is create a directory that points to that data I need to load. We'll call it AWR repo. Now that's been created, the first step will be to load that AWR data in. Now, all of these steps don't have to be done in the container database like we're doing in this demo. It can be done in a pluggable database. It's whatever suits your needs. So we'll use the standard AWR load script to load in the AWR data. We will select the directory I've just created. And we'll select the dump file, the AWR data. So we can see this here. We don't add in the .dump, so it's just the file name before the .dump prefix. And this will load the exported AWR data into our AWR data on this database. Now this will vary depending on how much data we're importing in. In our case, this is a demonstration, so there is not that much data, so it should be fairly quick. There is a log file called AWR, well, the name of the file name .log, that will be placed in the directory, and we should check that to make sure there's no errors once the data has been loaded in. For the in-memory advisor, it's obviously important we've captured workload that's analytical or doing warehouse type operations. So the in-memory option is not suitable for OLTP, and the advisor is looking for analytical or warehousing type operations. So the load has finished. Let's just come out of SQL Plus and just have a quick look at the log file that's been generated. Again, in a real world environment, we would take a close look at this. I can see the data has been successfully completed, and as I scroll up through, I can't see any errors. Obviously, I would spend more time looking at this if it was a real world example. So we know the AWR data has been loaded in, and now we need to load in the augmented data that complements the AWR data. So we'll use a script that is under the in-memory advisor directory, and where we use the IAM advisor AW augment export to get the data out, we will use the import script to pull that data in. We'll of course use the same directory because the files are in the same location. We will select the dump file, again without passing in the .dump. And we can see that it's pulling in that extra data. Again, depending on how much data it needs to pull in, depending on how big the export was, will depend on how long this takes. We're using small files, so it should be relatively quick for us. So we can see that the data has been successfully pulled in, and it's granting access on that AWR augment schema to the advisor. So we've loaded our AWR data, we've loaded the augmented data that complements it, and now we need to run the advisor itself. So this is done again via one of the scripts within the in-memory advisor directory, and this is called the IMAdvisor recommendation script. So let's run that. So the recommendation script can continue from previous recommendations if you've run the script multiple times. So if we'd run the script before and it had created tasks, we can revisit those tasks and make changes and get new recommendations. As this is the first time we've run it, there are no tasks, so we'll just hit return. So the advisor can run on a live system. You don't have to export the data out and import it to a remote system. It can run live. But it's recognized that we have augmented AWR data, which has been imported from another database. And it's asking, do we want to run against that or do we want to run live? So we're going to say, let's run against the augmented data. It's asking for the DB ID. This is the DB ID of the data we've imported in. So let's select that. And now it's asking what size do we want to recommend against. So how big do we think we want our in-memory store to be? So we don't have to basically select anything here, but for this example in 19C, you can use the in-memory base feature, which gives you 16 gigabytes for free. So let's type in 16 gigabytes, and this will then return recommendations based on a 16 gigabyte in-memory store. It's asking, from the data we've loaded in, is there a particular point in time where we want to start and where we want to end? So do you want to just focus in on one particular part of the data we've loaded in? We're going to just select the default, which will be the first snap, and for the end time, it will be the last snap. It's now asking whether we want to consider particular objects and how they would benefit from being in memory, but we're going to look at all the objects, so we'll just hit enter. So the in-memory advisor is now adding statistics. It's now going to run the recommendations, and it's going to come up with two files. It's going to come up with an HTML report showing us what it estimates to be the benefits of running in memory for a 16 gigabyte store, because that's what we selected. And it's also going to provide a script file, which will basically make the changes needed to implement this should we decide to go forward. This shouldn't take too long to run. So as before, a task is being created while we're running this. If we were to run this recommendation script again, we could actually then connect to this task and then make changes and then get new recommendations, or we could create a new task. So it's added the statistics, it's analyzing those statistics now to come up with the recommendations. We can see that we selected a size of 16 gigs for the in-memory size. So the advisor is now optimizing for that size. Of course, we could go back and change this, try a smaller size or a larger size if needed. There are some advantages of running the advisor directly on the system, the live system, because it will then be able to pull in and use the compression advisor to get more accurate compression estimates. When we run the advisor remotely, like we're demonstrating here, compression is, or the compression advisor is not used, and it estimates compression, so it may not be as accurate. We can see that the advisor is finished. You can see the task. So if we were to go back in, we could select this task and change it. And we can see that it's created two files for us, a DDL file, which will basically implement the recommendations it suggested, and the primary report HTML file. So I have a sample HTML file of the report. So that's this. So this is an example of the report that it will generate. If we go through this, we can see the first thing it's telling us is, out of all of the time it's analyzed, how much of that time was spent on an analytic like workload. And we can see in this example, 99% of the time it was doing, the database was doing analytical type of work. So obviously we want this number to be high because we want the in-memory advisor to work on analytical or data warehousing type workloads. If we then scroll a bit further down, we can see it's given us different in-memory sizes up to the 16 gigs that we specified. And we can see it's recommending at the 16 gigs, we should see a 9 times performance improvement if we were to implement in memory. It's showing us the estimated analytical processing reduction in seconds and the percentage maximum of the SGA size. So the SGA size was 50 gigs on our test database, as we'd be using 32% if we went for 16 gigs. We can also see that actually if we went for 4 gigs, which was not what we selected, we're using obviously a lot less of the SGA, it's only 8%, but we can see the performance improvement is still 9, and the reduction in processing times is exactly the same. So from this recommendation, we would say that a 4 gigabyte in-memory size would be optimal. If we then drop below 4 gigabytes, we see that we're not seeing any improvement. In the following section, it's showing us the top SQL statements that would benefit. It's showing us the SQL ID, the text or the beginning of that SQL ID, the processing time used in seconds. So if we look at the top line, we're seeing that it currently took 1,253 seconds. And if we were using in memory, it estimates it would only take 1,107 seconds. So this is basically giving us, for this particular statement, a performance increase of 8.6 times if we were to use a 16 gig in memory size. And we can see the top statements that are going to benefit. And again, in the next section, it shows us the objects it recommends to place in memory to get these benefits. So we can see the tables that it recommends to put into in memory and the type of compression we may see from using in memory on those objects. Then gives us some information about the database itself. And then at the bottom, it actually provides the implementation script. So these are the scripts these are the commands to run to place the objects it's found into the in-memory store. I hope you find this video useful, and this ends the demonstration.